Welcome back to the second part of the test review on quadratics, graphing, characteristics, transformations, and converting. We are picking up with number 11. This one, we have a quadratic that's already graphed for us to the right, and we just want to find all these characteristics. So I actually want you to pause the video right now and try to fill these in, and then come back and check your answers with mine just so we can see. All right, go ahead and pause it now. Okay, let's talk about this real quick. There's a lot of scribbles on my graph. Domain and range. Remember, domain is x's, range is y, so domain is left to right. So you'll see the purple at the top of my graph where I've got arrows going to the left and the right. It shows that it's going to go from left, negative infinity, to right, positive infinity, because arrows go on forever in two directions. The range is your y value, so that means the lowest y value to the highest y value. Our lowest y value is a -4, and that's a point on the graph, not an arrow, so it gets the bracket. And I've got that labeled in purple as well. And then it goes up forever, which is y values that are increasing forever, which is positive. Our vertex is at 1, -4. The axis of symmetry cuts the graph in the middle and also goes through that vertex, so it's at x equals 1. That is needed, x equals. Remember, zeros mean x-intercepts. That's going to be at -1, 0, and 3, 0. Those are points on the graph, so they need to be ordered pair. Your y-intercept is also a point on the graph that crosses the y-axis. That's at 0, -3. I did in orange the intervals of increase and decrease. Remember, these are going to be x values that are separated by the axis of symmetry. So from the axis of symmetry, which is at 1, we see the left side has a negative slope because it's going down from left to right. So that means that side, the left side, is our decreasing. So decreasing interval is negative infinity to 1. Then the right side of the axis of symmetry is all positive slopes. So that's from 1 to infinity. Our vertex is that should be circled a minimum. Minimum, and it's at y equals a -4. Our end behaviors as we go to the right, which is positive infinity, as we go to the right or as we go to the left, both ends of the graph are going to go up forever, so the y values, or the f of x's, are going to approach infinity. And then our average rate of change from -1 less than or equal to x less than or equal to 2, that just means find where x is -1 on the graph. So you'll see that's the green dot on the left at -1, 0. And then find where the x is 2. So when x is 2, the graph is down at -3. So all then you need to do is find the slope between those 2 points that you just found, and it's going to be down 3 over 3, which is -1. All right, so let's move on and look at these ones. These ones are kind of very involved. There's lots that we're doing. We're going to graph them and write them in a different form. So first, let's graph this. This is standard form, so that means let's find the axis of symmetry first so we know where the middle of the graph is. So we are going to do negative our b value divided by 2 times our a value. This gives us a -6 over a -2, which is -3. So that means our graph is going to split right here. That helps us know where to look on our table. So that should be a +3. I drew it at +3. Don't know why I wrote negative, my bad. So when x is 3, that should be the middle. So we want some nice points to the left of that. So that would be smaller x's, 2 and 1. And then 2 points that are nice to the right of it, which would be 4 and 5. We're going to let our calculator help us get those points. So I'm going to go to table. We're going to clear out what we have and type in -x² plus 6x minus 5. I'm going to start my table at 1. And we're going to see that our table is going to tell us 0, 3, 4. And then it should have symmetry 3, 0. So 0, 3, 4, 3, 0. So let's plot this 1, 0. Then the order pair 2, 3. Make sure you're okay. These have half lines too, so make sure you're paying attention to the numbers. 3 is 4, and then 4 is 3, and 5 is 0. Please make sure that all your important points are plotted. That means you need to have your x-intercepts plotted, which we have those plotted, okay? Our y-intercept plotted, well, here I don't have my, well, let's look at the table. Your y-intercept is where your x is 0. So when x is 0, our y-intercept is all the way down here at -5, and I don't have that given, so that's okay to not plot it, so we're okay with that. Then you have to make sure your vertex is plotted. These are the important points that have to be plotted. Okay? So once you have all those, go ahead and you can make your parabola. Remember, it should be a U. There should not be straight lines, it should be curvy lines, and you should continue in that same pattern. Okay, so here's our graph. Now we just want to change it to vertex form. That means we need the vertex. Well, we already have the vertex. It's right here. So it's a 3, 4, which was also that middle point here. And we know what our A is because it's given to us in the standard form. It's -1. So vertex form is going to be -1. You can put the 1 or you don't have to. Times x. Remember, opposite of the x of your vertex, and squared, plus your k, which is the y of your vertex. All right, this next one says we're going to graph it and write it in intercept form. So remember, if we have a standard form, the easiest thing when we're graphing is to find our axis of symmetry. So -b over 2 times a. So this is -8 over 2, which is a -4. So our axis of symmetry should be cutting this right in the middle at -4. Okay, that tells us where to look on our table. So we're going to put the -4 in the middle. We want 2 nice points to the right, so those are smaller numbers, which is -5 and -6, and 2 points to the right, which would be bigger numbers, -3 and -2. Again, we're going to use our calculator to help us get these ordered pairs. So we're going to type in x squared plus 8x plus 15. Okay. And we're going to start this at -6. And we're going to get 3, 0, -1, a 0, and a 3. So 3, 0, -1, 0, and a 3. Okay, so let's plot it at -6, it's +3. Again, be careful with the lines, make sure you're doing it on the right lines. -5, 0, -4, -1, -3, 0, and -2, +3. Okay, on this one, if we were going to find our y-intercept, we would need to find when x is 0, and we would find that that's 15. We can't plot that, so we know we have our x-intercept graphed. Our y-intercepts we can't because it's not on this graph provided, and our vertex. So we can go ahead and connect these. Again, you want to make sure that you connect it with curvy. Try not to make straight lines, arrows on the end. Now, if you remember, we said that these were our y-intercepts, and remember, in standard form, your y-intercept is always the c of standard form. Okay, that's only for standard form. Now let's write this, number 13, in intercept form. Well, that means we factor this. If we factor this trinomial, we need 2 numbers that multiply to give us 15, add to give us 8. Well, if I have a 5 and a 3, that multiplies and gives me 15 and adds to give me 8. So those are the 2 factors that we need, x plus 5 and x plus 3. Notice that those are our x-intercepts except with the opposite signs. Okay, the only other piece we need here is if there's an a, and there is no a on here. We did not factor out a GCF, so it's just going to be y equals x plus 5 times x plus 3. Okay, and again, those are our x-intercepts if we change the signs, if we set them equal to 0. All right, almost done. We've got number 14, 15, and 16. So this one is in vertex form. We're going to graph it and then write it into standard form. So what's nice, the vertex form gives us the vertex, opposite of the x, and leave the y, which is our k, alone. So -1, -2. So this should be the middle. So I'm going to get a table. I'm going to put the -1 in the table. We want 2 numbers smaller and 2 numbers bigger. And we're going to use our calculator to get our values here. So go to the table. We're going to type 3 parentheses x plus 1 squared minus 2. This one I'm going to start at -3. And we're hopefully going to see symmetry. So I've got a 10, 1, a -2, a 1, and a 10. 10, 1, -2, 1, and a 10. So let's plot this. -3, positive 10. -2, positive 1. -1, -2, 0, 1, and 1, 10. Okay, we're going through. We've got our vertex plotted. That's good. We've got our y-intercept plotted. Right, it's right there. But we don't have our x-intercepts plotted. We need our x-intercepts. So let's right now solve this. We need to take this equation right here and we need to solve for x. So we're going to solve by square roots. So set it equal to 0 because x-intercepts have a y value of 0. And we've got our equation and we're solving. So add 2 to both sides. Divide both sides by 3. So we get 2/3 equals x plus 1 squared. Square root both sides. So we get a plus or minus square root of 2/3. That's okay. Equals x plus 1. Get x alone by subtracting 1. So x is going to be equal to a -1 plus or minus the square root of 2/3. Okay? We just need to make sure that we're putting those points in the right spot. So go to the calculator, clear the screen out. We're going to do -1 plus the square root of 2/3. We're going to find out that that is -0.18. So -0.18 is going to be about here. And then we're going to get the other one by doing -1 minus the square root of 2/3, which is -1.82. -1.82, which is going to be about here. So that should coincide with what we have. And it's important that you clearly mark with a point plotted on your graph so you have the points that you need. And then we're going to make a parabola out of it the best we can. Make sure you go through those important points. Okay, so now we've got our x-intercepts plotted. So now we're just going to change it to standard form. So please remember, when you're changing vertex form to standard form, you need to follow PEMDAS. All right, so if we've got this, x plus 1 squared minus 2, we're going to change this to standard form, taking care of this first. So either do a box or do distributing. And we are going to get x squared plus 2x plus 1. Then distribute this 3. So y equals 3x squared plus 6x plus 3 minus 2. And then we get the final by combining those like terms. Y equals 3x squared plus 6x plus 1. All right, so I want you to try to do number 15 and 16 right now on your own, and then come back and check them with mine. So go ahead and pause it. All right, so number 15, you needed to make sure that it was in vertex form, and your A should be a -1/4. That accounts for the vertical shrink of 1/4 and the reflection. Then the inside the parentheses should be an x minus 6, which accounts for moving it to the right 6. Remember, that's the opposite sign. And then the plus 2 at the end represents going up 2. Number 16, we have average rate of change. Remember, that's slope. So if you don't have a graph, you're going to want to do y2 minus y1 over x2 minus x1. If you have a graph, just count rise over run. So I made a table first, and I put my x's, -1 and 3, and then I used a calculator to find the y values. So we got a -8 and a 0. Then I just labeled x1, y1, x2, y2, and I plugged them right into the equation. So we get 0 plus 8 divided by 3 plus 1, which is 2. All right? Study well.